All right, hey everyone. My name's Farhaan, so I'm the tech lead at Maple Finance. Just a bit about Maple Finance. We're an institutional-focused DeFi borrow-lend platform trying to bring capital markets on chain. So today, so the name of the talk is, best practices to deploy safely on chain. But actually, for me, it's more about best practices for on-chain ops. So what do I mean by on-chain ops? So the focus tends to really be right now on, whenever we're talking about building smart contracts, people talk about the pre-build phase, the build phase, and testing. So you might have seen a lot of these things mentioned before. So when you're designing things, like what are the requirements for the system you're building, your threat modeling, your economic modeling. When you're building, you've got your engineering processes, but testing, this is where we spend most of our time building smart contracts, if we're honest. It's like your unit, your integration, your fuzz, your invariance, mutation testing. If you want to play around with stuff like Gambit, your formal verification, red team exercises, which are good fun as well, when you get together and just try to break your contracts on like an offsite or something. And then what's the most expensive bit usually is your audits. So internal audit on the team is usually fine, and then you've got your external audits. But I don't want to talk about this stuff today because this has been talked about a lot before. What I'm focusing on is what, as smart contract engineers, is our DevOps, basically, our on-chain ops. So what are we going to talk about? So 3 sections, essentially. So I'm going to talk about the preparation for deployment, the actual deployment process itself. So whilst for some of you might think, okay, it's just deploying the smart contracts, but sometimes it's not as simple as that, especially if you've got really complex systems. So for example, at Maple, the Maple core protocol itself is around 20 smart contracts. Most of them are upgradable. They're all modular, so they are not fully dependent on each other, so you can upgrade parts of the system. And that's really good for like a development process of like a product where you might want to change one part of your system, but not the entire system. And you've got a live system with hundreds of millions of dollars in them. How do you safely upgrade and develop for this protocol? And then, we'll talk a bit about the post-deployment process as well and what goes into that. So in terms of deployment preparation, so I'm basically talking through like what we do at Maple. So hopefully you guys can take something away from this. So to start things off, we always do fork testing. So this is really easy to do with something like Foundry now, where you can just like set the RPC. And what we do is we fork our current protocol and then run all the upgrade that we need to do. So, deploying the contracts, doing all the configuration, and then asserting all the state diffs that we expect to happen. So, is the factories pointing to the new contract version? Have the contracts been upgraded pointing to the right implementation? Are all your configuration variables set properly? So that's kind of like a base thing that everyone should be doing in our opinion. Then of course deploying to testnet is always great, especially if you've got like your wider engineering team building the front end, the middleware layers like your subgraph and stuff, and just hooking into your contracts and making sure that everything works appropriately there. Another thing we like doing is what we call user lifecycle testing. So the fork test that I talked about previously is just more about focused the actual upgrade itself, but how do you make sure the upgrade works as expected? So we like to do essentially a complete user journey from start to finish, depositing into the protocol, a loan being sent out, yield being generated, a user then withdrawing either partially or fully. And you can also fuzz this as well. So we've built some utils internally where we kind of basically fuzz random actions against our protocol to do this. And then the thing that takes a lot of time actually, depending on how big the upgrade is, what we call dry runs, which I'll get into deeper in a sec. But essentially rehearsing against forks. And another thing you can do is actually prepare multi-sig transactions ahead of time. So I'm hoping most of you guys, when you have upgradable contracts, they're not controlled by a single private key. It's usually a multi-sig. There's usually a safe. So one thing you can actually do is, so on Safe, when you go and build a transaction, there's this transaction builder, but you can usually just import a JSON file, which has all the transactions already pre-generated. And this is especially useful if you need to dynamically generate change of addresses or params as part of like your upgrade process. So how do we actually do this? So the deployment process itself, we think should be boring and uneventful. We kind of see it as like a militaristic exercise of like, you know exactly you're doing A, B, C, so a checklist is super good for us here. So this is an example of a checklist from a recent upgrade that we did. So you can see that usually it's split out into different sections depending on if it's on mainnet or like another L1 or L2, for example. No alpha there. And you can see there's different steps in that. So there's like preparation stages, the actual transaction, but then also there's this thing called validation around that as well. So, all right, where are we at? So the deployment process, so yeah, we've got the checklist, you've done your deployment. So we use Foundry, so you use Forge scripts to do this, to deploy your contracts. And what we do is we run the step on the fork. So we use Tenderly for this, so just talking you through how we do this. So this assumes that your upgrade isn't atomic, which might be difficult to do depending on like how your protocol is set up. For us, usually an upgrade process isn't fully atomic. We try to make things as atomic as possible, but that might be difficult to do in practice. So why do we prefer using Tenderly? So we're not shilling for Tenderly. We're heavy power users. We pay them heavily for every service that we get, but they're great. But it's using a Tenderly fork is super good for the non-technical multi-sig signers as well that you have, because I'll show you in a sec. There's like a nice simulation that happens. You can see exactly all the state diffs that are happening. So this is from Gnosis Safe. So you can see here, just for example, we want to pause the protocol. You might want to do this before you're doing an upgrade. So there's this simulate button as part of the flow. So when you click that, it goes and takes you to Tenderly and it runs this simulation. Now, what we do then is there's this button here on the top right. It might be small to see, but it's called Run on Fork. So we actually, when we were doing our big liquidity migration for the V2 upgrade back in December 22, we were moving about $300 million of TVL across to the new version of the protocol, and we wanted to sim this heavily. So we actually worked with Tenderly to make sure that this was available to us as a feature. So yeah, you can now just run on a fork. And then you get this RPC URL as well associated with the fork. So why is this important? Why not just do this locally using Anvil or something? So the awesome thing here is when you've got the RPC and you've done your transaction against this fork, now you can run what we call validation scripts against this. So essentially these are another version of fork tests where you can assert all the state diffs for this specific action that you expect to happen. So that's what I'm talking about at the bottom here with the validation scripts. There's a fork of mainnet and you can check each state diff, and it looks something like this in our case. So we just a function called run. So you can see here we're upgrading our globals contract on ETH mainnet. So what's hidden here is the setup function. All the setup function is just doing is just forking from the latest block. So you can see here we've got logs in here. We check if it's like the correct implementation. Usually there's some helper functions here that are abstracting away some of the more intricate checks that we expect. But this gives us confidence that the system that we've upgraded has been upgraded in the way that we expect it to be. So yeah, super useful to do this. Feel free to check out our repo at Maple Core for more examples of this. And to round things off, so just to kind of cover what we've done, so you've got this checklist, you've run through each step, you've done it against the fork. Each step before you do your actual transaction on mainnet, you run your validation script against it, so you're confident that your system's been upgraded the way that you expect. But one thing also that's important to do is to make sure you've deployed the right contract. So this is actually a painful way to actually check before, because you might have had an audit and the audit's at a specific commit. So how do you know one of your dev team hasn't just accidentally deployed like the wrong contract on the wrong commit, for example? So you want to do bytecode matching essentially. So there's a new feature from Foundry that just came out I think 2 weeks ago now. So shout out to the Foundry team. Thank you for constantly developing for us. But yeah, you've got Forge verified bytecode now. So what you can do is you can pass in the address, and if you do this in your repo for your contract, pass in the contract name as well, and it will do a match essentially for the bytecode that's sitting on the RPC that you've provided. So if in this case mainnet, and check if it's like a full match or a partial match. You may want to do a partial match if you've maybe changed the name of your contract and your metadata hash has suddenly changed. So that's super useful as well. So definitely don't forget to verify that the right contract is deployed, because that happens where people deploy the wrong contract. All right, let's talk about post-deployment. So you have to verify your contracts, of course. Don't need to get into that too much. Of course, having a bug bounty program is important. So there's a lot of work actually happening from the Security Alliance. So Sam Cizi-san, like from Paradigms, spearheading this. So there's some cool initiatives there, like the Safe Harbor Agreement, where you can basically sign up to have a process for white hats to recover funds and send them to a specific address. And this is all pre-agreed upfront. So yeah, hopefully that helps with folks wanting to be more white hat than black hat in terms of hacking. And then incident response, so always having a playbook, not thinking in the moment. Again, you want to just like act and know exactly what you're going to do. And doing drills for war rooms. So yeah, the Security Alliance actually does war room games for you as well. So you can reach out to them and be like, hey, please run a war game for us, pretend hack our protocol and make us work. And then lastly, everyone needs to do some sort of monitoring for their system. So informational monitoring, that's pretty simple. If you're doing like, someone's deposited into your protocol, maybe you want a Slack notification going in. But I want to dig a bit deeper into how we do critical monitoring. So, how to automate the UOP process. So how we do critical monitoring at Maple is we've got a set of system invariants. So this helps with our invariant testing that we do. And then what we do is for each invariant, we've basically bunched them up together in a helper contract that then we deploy on chain. And what happens is we ping that contract and check every block if all the invariants are still holding. You may need like different sets of helper contracts. So we have one that relies completely on-chain data, and then we have another that relies on off-chain data. So what we mean by that is maybe you need to pass in an array of lenders to check like all the total balances add up the way that you expect, for example. And then you can set up a cron job to do this, to check. So we use Tenderly Web3 actions for this. So again, Tenderly coming in clutch with all their products. And essentially a PagerDuty notification would go if any of the system invariants break. So yeah, no, knock on wood, haven't had one of those situations yet, but we do drills for that, and it's always very scary when one of those come up. So just to kind of show you how we've set this up on Tenderly, so you can see this is an example of a Web3 action. So this is actually live in production right now. So this is checking our protocol invariants every block. Which is super great. And then, yeah, it'll let us know if something's broken. Hopefully not. So yeah, that's my talk on on-chain ops. Hopefully you guys learned something and took away at least one thing from it. And yeah, cheers. Thanks for listening. And you can follow me on 0x Farhaan on Twitter if you want to see more about what we're up to. Thank you.